Today we're going to learn about how to solve some basic exponential equations. But before we start doing that, I do have a reminder for our rules of exponents. And one of the things that I want to point out here is if we have negative exponents, how we make them positive. So if we look at this rule right here, remember that if we have something like 2 to the negative third, if we want to make that exponent a positive, we just move this down to our denominator. So this ends up being 1 over 2 cubed, and we know 2 cubed is just 8. Um, on the flip side, if we have something like 1/4 to the negative third power, to make this a positive power, we end up flipping the base of our exponent. So this ends up being 4 to the third power, and 4 to the third power is 64. So you always want to make sure that you make your exponents positive. Um, and we have some other reminders here or of our exponent rules as well that you all can review. Now this chart right here, we will use this for one of our problems that I do right here, and then you also may want to reference it for your homework in Delta Math. So let's talk about first the one-to-one property of exponents. So what this says is that if you have a to the x equals a to the b power, you'll notice here that both of the bases of the exponents are the same. And so when the bases of the exponents are the same, we can actually set these powers equal to each other. So we know here that x has to be equal to b. So I want you to notice that these have the same bases, that terms have the same bases. So that's why we're able to set those powers equal to each other. Okay, so let's go through some examples of how we can use this to help us. You notice here that each exponent term has the same base. So we've got the same base, and because we have the same base of 4 in both of these problems, we can set the exponents equal to each other. So here, this one's pretty straightforward, and we can write the equation just x equals 3. There's nothing to solve. We just know that x equals 3. Now, if we look at this next problem, we also notice that each term has the same base. So we have 4 to the x equals 4 to the 3x minus 8. So because those bases are the same, we can set their powers equal to each other. So we could say here that x equals 3x minus 8, and then we have a pretty easy equation to solve. We can just combine our like terms. So we end up getting 2x equals 8, and so here x is going to be 4. Now let's go into one that's a little bit more interesting. You notice here that if we look at what we're given, we have a base of 5 on the left-hand side, so 5 to the x minus 9 equals 125. So these are not the same base. But the question you want to ask yourself is, can you write these so that they will have the same base? And I'm hopeful that you recognize, oh, 125 looks familiar. I can write 125 as 5 to the third power. So we have on the left-hand side, 5 to the x minus 9 equals 5 to the third power. So all we did was rewrite 125 as 5 to the third power. And so now we get to a situation where we do have the same base now at this point, and because we have the same base, we can set our powers equal to each other. So we have x minus 9 equals 3, and if we solve this simple equation, we get that x equals 12. So you'll notice so far, if we don't have the same bases, we try to find them. So I want you all to try number 4. I want you to try number 4 and number 5 on your own and see if you can come back and check your answers. So hopefully for number 4, you recognize that 36 could be rewritten as 6 squared, and then because you have the same base, you can set your powers equal to each other, and you get x equals 3. Same for number 5 here. Hopefully you recognize that 81 could be written as 3 to the fourth power, and now that you have the same bases, you can set your powers equal to each other. Now number 6 provides an interesting situation. So we have 32 to the x power equals 4, and we notice right off the bat that these are not the same base. But let's think about it. Can we rewrite 32 as 4 to some power? And you probably recognize that you can't do that. So what you want to do is try to figure out, how could you rewrite this? I want you to imagine here that you can rewrite 32 as 2 to some power. So that's going to be 2 to the 5th power. And then if we rewrite 4 as 2 squared. So here we said we wanted to rewrite 32 as 2 to the 5th power, and that's 2 to the 5th power, all raised to the x power. And then 4 is just 2 squared. Now, knowing our properties of exponents, when we have a power raised to a power, we just multiply them. So you have 2 to the 5x equals 2 squared. And now we have our same bases. So we have same bases now, so we can set our powers equal to each other. So we have 5x equals 2, and if we just solve for x, we get x equals 2/5. So even if they both, if you can't get initially the base is the same just by looking at the numbers given, I want you to think outside the box, just like we did here, and recognize that we could rewrite 32 with a base of 2 and 4 also with the base of 2 as well. So that ultimately we got to an equation that had the same bases. Now let's look at this last problem. Let's look at this next problem right here. I want you all to try this on your own and then come back and check your answers. So here, this may have taken you a little bit to figure out what the common base was here, how we could rewrite 32 and 64. You know that 64 could be written as 8 squared, but that doesn't really help you because 32 can't be written with a base of 8. And maybe you also look to see that 64 could be written as 4 cubed, but again, that doesn't help us because 32 cannot be written as 4 raised to some power. So we had to go down and rewrite 64 as 2 to the 6th power, and then we had to write 32 as 2 to the 5th power. Again, don't forget that you are raising a power to a power. So on the left-hand side, you distribute the 5 to the x plus 2 to get 2 to the 5x plus 10, and then that's going to equal 2 to the 6x, and then setting your powers equal to each other, you have an easy equation to solve, and you find x equals 10. So this last one, you may be looking at it and thinking, oh my goodness, Miss Elrod, what in the world are you thinking? First, you notice here that these do not, so these are not the same bases. And so we somehow have to rewrite these big numbers, 262,144 and 496 as a number raised to some power. And this is where this handy dandy chart can come into play. If you notice here, if we look out, you see that we have 4 to the 6th power is 4,096, and 4 to the 9th power is 262,144. So we can use that chart to help us with these really big numbers. So here we know that this right here is 4 to the 9th power, and we still have it raised to the 4x plus 6. And then 4,096, we found that was 4 to the 6th power, and that's still raised to the minus x minus 15. So now we've gotten it to a same base. You will want to use the power rule to raise this a power to a power. So we have 4 to the 36x plus 54 power equals 4 to the negative 6x minus, and that's 80. 6 times 15 is 80. So now we do have same bases, and again, just like we've done before, when we have our same bases, we can set our powers equal to each other. So 36x plus 54 equals minus 6x minus 80. And then if we just combine like terms, you have 42x equals negative 134. Hopefully I'm doing my math right. And then we can just divide both sides by 42 to solve for x. Hopefully you recognize that I made that mistake, that 5 times 6 ends up giving you 90 here. So you end up having 42x equals negative 144. So we have negative 144 over 42. And if we reduce that, we'll end up finding that 6 goes into both of them, so we have negative 24 over 7 as our answer. So now let's take a look at a few more interesting ones. Here we see that we have 1 over 27 raised to the x power equals 9. So we recognize here these do not have the same base, and we need to figure out how to write them as the same base. So if we look at 1 over 27, we do realize that 27 is 3 raised to the third power. So we can rewrite 1/27 as 3 to the negative third power, okay? Because remember, 1 over 27, 27 is 3 to the third power. And if we want to write that where our base of 3 is in the numerator, that's the same thing as 3 to the negative third. Now we also want to rewrite, and this one's a little bit easier, we want to rewrite 9 as 3 squared. So now let's pull this back over to our main equation. So 1 over 27 is the same thing as 3 to the negative third power, and it's still being raised to the x power, and that equals 3 squared. So because we have the same base, now we can set our powers equal to each other. So we have negative 3x equals 2, and so x is going to end up equaling negative 2/3. Now, I want you all to try this next one, see if you can write this with the same base, and then we'll come back together. So hopefully when you looked at this problem and recognized they did not have the same base, you went one of two routes, and I'll go through both options here. The first option is you could rewrite 1/64 with the base of 4, and you could also rewrite 1/4 with the base of 4, and let's talk about how this would come about. You know that 1 over 64 is the same as 1 over 4 cubed, because 4 cubed is 64, and we could rewrite 1 over 4 cubed as 4 to the negative third power. And 1/4 we can write as the same thing as 4 to the negative 1 power. So now we're going to put this back into our equation. So instead of 1/64, we're going to write 4 to the negative third power, and instead of 1/4, we're going to write 4 to the negative 1 power. And now using the power rule, we know this intermediate step right here is just you have 4 to the negative 3x power and 4 to the negative 1 times x minus 5 power. And so then you're just going to set your powers to each other and solve for x, which you end up getting x is negative 5/2. Now the other option, if you didn't realize that you could rewrite this, both of those fractions with the base of 4, you could rewrite them with the base of 2. Because we know that 64 is the same thing as 2 to the 6th power, so 1 over 64 is the same thing as 2 to the negative 6th power. And likewise, 1 over 4 is the same thing as 1 over 2 squared, or 2 to the negative 2 power. So then we just plug this back into our main equation. I have 2 to the negative 6 power, then raised to the x power, and it equals 2 to the negative 2 raised to the x minus 5. Again, this intermediate step where you're multiplying your powers, you can write that in right here, and then you set your powers equal to each other to solve for x. Either way, you end up getting the same answer. It's just whichever is your preference.